All right, thank you all for sticking around, and sorry for some of the technical difficulties here. I'm going to be doing something a little off script. I'm going to be running this presentation from somebody else's computer. Hopefully it'll work out right. That obviously rules out any kind of demo that I was going to do. But we're going to talk today about Istio security, but now specifically in terms of ambient mesh. So we released ambient mesh, as you may have known. We've been talking about it quite a bit today. It's pretty exciting. Alternative data plane, a sidecarless data plane for Istio. But I want to go into a little bit more depth around how we maintain some of the properties of zero trust for the service mesh, because a big part of our journey into kind of improving the operationability of a service mesh, we did not want to trade off or give up any of the benefits of security and the zero trust capabilities that you get in a service mesh. So again, my name is Christian. I'm a global field CTO at Solo. Been here for 4 years now. Before that, I was at Red Hat and was involved with Kubernetes from the very beginning, involved with Istio since before it was publicly released, and been working a lot with our customers and with the open source community and open source project, contributing things like obviously things to the project directly and books and stuff that we've written, and a lot of that experience and the unique perspective that I think that we can bring from Solo to the open source project and to some of the innovation that we're building in the community, especially things like Istio Ambient. Lynn, I think we have copies of the book too. If you have interesting questions that you raise while we're here, we do have physical copies of our new book that was just released, I think, a week ago, called Istio Ambient Explained. We'll also have it at the booth tomorrow at Service Mesh Con and at the KubeCon Expo floor. Okay. Now I feel like if you've been here since the very beginning, or the early parts this morning, we went through quite a bit on Istio Ambient, some of the networking. I know Lawrence did a great talk about how the networking works in Ambient, and I'm going to take the security angle of this topic. But to set the stage, we have to remember that Istio Ambient is an alternative or optional data plane for Istio that runs in a sidecarless mode. So that means there are no sidecars being injected into the workloads, that things run transparently, as even more transparently than what you see with the sidecars. And to do that, we've layered the ambient data plane into a secure overlay layer, which handles, I think Louis mentioned this in the morning, just focusing on making the connections and establishing authentication and mutual TLS for those connections. We can also enforce authorizations at this level. So service A can or cannot talk to service B based on its identity. And so we use the cryptographic identity that you would see in Istio's sidecar model. We also use that same method in the ambient data plane as well. You'll see in these two layers that the secure overlay layer is, like I said, focused on layer 4 and is much closer to being pushed into the realm of the CNI than it is an application layer sidecar or L7 proxy. The L7 capabilities we still have around, and those run in the waypoint proxies, and those are opt-in. If you need layer 7 capabilities, then Istio Ambient can be configured to route traffic through those waypoint proxies and then apply things like header-based routing or request level retries and anything that requires parsing the stream and understanding what's happening, for example, in HTTP. Another thing that we'll cover and we'll touch on here is that we've also tried to reduce the attack surface of the mesh data plane itself, when it's running with the applications or when it's running close to the applications. And that'll make more sense as we go along here. So first of all, let's just look at the data path of Istio Ambient and how it kind of works. So your application workloads, they're running in a cluster, but this could also be extended out to running in a VM. All right. Now we're going to be talking a little bit more Kubernetes centric, but this is not tied to just Kubernetes. So your workloads are running, and through the redirection magic that Lawrence talked about earlier, the traffic goes from the workload, which thinks it's talking, in this case, service A to service B. It thinks it's talking to service B, but through that redirection mechanism, or eBPF, which is what Lawrence talked about, the traffic will be routed to this Z-tunnel component or agent that runs in the same node as the workloads. That Z-tunnel agent will determine what is that workload that's making the originating call, and then it will establish a mutual TLS tunnel. We talked about the HTTP-based overlay networking environment, the HBone protocol earlier today as well. And that mutual TLS connection will be established with the Z-tunnel that's running on a remote node where the destination workload runs. So that's in the case where there's no layer 7 needed, or you don't opt into the layer 7 capabilities with the waypoint proxies. And this obviously becomes a lot faster. If you don't need all the layer 7 parsing, then don't do it. It becomes faster if you just stay in the secure overlay layer, or just here in layer 4. Now, if you do need layer 7 capabilities, and the service mesh brings a lot of benefits to your application by knowing what's on the wire and able to understand layer 7, then that's when we configure the waypoint proxy. So in this case, we'll have a waypoint proxy that operates layer 7 policies for specific workloads. So in this case, service A is trying to talk to service B. We need to, let's say, inject fault injection or something for calls that are going to service B. So then the secure overlay components are smart enough to say, okay, you're trying to talk to service B, then I'm going to send you to the service B waypoint proxy. And then that will apply the layer 7 policies for service B. We also talked a little bit about the benefits, but I do want to re-emphasize that the benefits that we focused on at Solo when we started building Ambient with Google is the primary use case was around operationability. How do we simplify the operations of Istio? We know, working with our customers, working with massive deployments of Istio, we know that things like updating the control plane for whatever reason, whether it's new versions or patches, CVEs have cropped up. And this is going to become something that I point out a little bit later, that simplifying how you actually roll out these CVE patches and the updates and upgrades to Istio that's the operationalization that I'm talking about. These things around, in some paths we can improve performance. In some and we can for large services specifically, we can really reduce the cost of provisioning memory and CPU because we save on amortization of those resources. Those are nice, but those are not the main reasons why we built Ambient. It's for simplifying day 2 operations. So let's take a little bit closer look at how this all works. So when workload A tries to talk to B, it is going to communicate over the network, like I said, and it's going to be trapped and redirected to the Z-tunnel. The Z-tunnel runs as an agent or a daemon on the node. And what the Z-tunnel is going to do is going to look at what is the destination that it needs to send this connection to, the TCP packets to, and it's going to it'll have a list because Istio's control plane is also involved here. Istio's control plane is updating the Z-tunnel to tell it where the various workloads work, just like it does today in the sidecar model, right? Istio's control plane is updating endpoints and updating destinations about where the various services might run. It's doing the same thing here. So the Z tunnel is talking with the Istio control plane, communicating and getting information about where these services live. So that if service A wants to talk to B, the Z tunnel will look up, okay, you want to talk to B, here's where service B might be. Here are the endpoints that make up service B. And then when it tries to talk to one of those endpoints, it'll talk to the Z tunnel that's living on the node where service B is deployed. And what it'll do is it'll open up a mutual TLS connection, and it'll present a certificate that says, hey, I'm service A. On the other side, the destination side, we're expecting that side to return and say, hey, I'm service B. And now the mutual TLS connection can be established. So you'll note here that, I think you can see the colors here, right? That the red connections that happen on the node are unencrypted. That the green arrows between the workloads over the network are encrypted mutual TLS. And then again, on the other side, where the traffic actually gets to the workload, that's a red arrow again. Now, if you include the waypoint proxy, actually, I just literally wrote these slides an hour ago. I don't know the order of them yet. If you have this mutual TLS in place, you can also write network policy or authorization policy about what services are allowed to talk with which other services. So the Z tunnel on the receiving side, on the destination side, can say, oh, I see a connection coming in from service A, but I have a policy in place that says A can't talk to B, A can't talk to this service. So at the Z tunnel, we can enforce authorization policies based on this cryptographic identity. So we can get authentication and authorization just by deploying the ambient Z tunnel data plane. Now, if you need to do more sophisticated checks, like, does it have this JOT token, and are these claims in there, and does it have these headers? That's all layer 7 stuff. So that would have to be done in the waypoint proxies. That would not be able to be done in the Z tunnel or in the secure overlay. So now, how does the Z tunnel? So if it's presenting certificates on behalf of application A, how does it get those certificates? In the sidecar approach, if you're familiar with Istio, what the sidecar does, so the sidecar actually runs a proxy and a little agent that runs with the proxy. And that little agent, as it's bootstrapping the sidecar, the actual proxy, is taking its identity token that gets mounted in a pod if we're thinking through Kubernetes, right? It takes its service account token, and it calls the Istio control plane with a certificate signing request. And it says, hey, here's this token, sign this request, I'm service A. Istio control plane says, okay, yeah, I'm validating, you look like service A, let's sign the certificate. But in the ambient mode, the workloads don't have a sidecar, they don't have an agent that runs with them. So that agent, that process actually happens in the Z tunnel now. So the Z tunnel will say, here, this is my token, this is my identity token, service account token, when it calls the Istio control plane. And it says, I need the certificates on behalf of service A. And the Istio control plane will look at the token and say, yep, you're the Z tunnel running on this node. Yep, looks like service A is running on that node. Okay, so here's the certificates for you. But if it determines that Z tunnel is not allowed to run that service account, it will reject that CSR. So now the Z tunnel, for any of the workloads that are currently running on that node, not ones that happen to be running before and are not gone or future running, it's the workloads that are running on the node at that time, the Z tunnel can request the certificate material for those workloads. So in effect, if you have a lot of workloads running on that node, you'll see that the Z tunnel is, it has the certificates for each of those workloads. As workloads go away, those get cleaned up, and you're left with a set of certificates and identity material that is relevant for the workloads that are running on the node at that time. Now, if you put the waypoint proxy in this request path, so the mutual TLS that you would expect, that we saw at least right here between A and B through the Z tunnels, now that mutual TLS between A and B terminates at the waypoint proxy. So the Z tunnel will open up the connection to a waypoint proxy if it's been configured to do that and if there's layer 7 policies that need to be enforced. And you'll see that the mutual TLS between A and B will happen at the waypoint proxy. But the waypoint proxy, when it sends that connection down to the actual target workload, will go through a Z tunnel and will also be mutual TLS. But this mutual TLS is not going to be between the source service or the originating service. It'll be between the waypoint proxy and the Z tunnel. And in this case, since this is the service B waypoint proxy, it'll actually be the identity on both sides will be for service B. We should probably stop saying B. But both sides will have the same identity. There'll be different certificates. If you look at the serial numbers, they'll be different. But they'll be rotated individually and all that. But they both represent the same identity because it's just the B waypoint proxy talking to the B service through the Z tunnel. Okay. So those are the components. So some of the steps that have to happen to be able to get the certificate material, to establish the connections. Now let's take a look at some of the the implications of this and how we maintain some of the zero trust properties. A big part of maintaining that zero trust is that nobody can intercept the traffic over the network. Nobody can eavesdrop and change the traffic. That policy is enforced down to the scope of the applications. And that policy and how that changes can be done dynamically. So we have to think about what are the areas of attack and how could this be compromised? And there are 3 main areas that we think of where if there are attacks and if there is compromise, then we have issues. The first is the application. When we talk about service mesh, we talk about application networking. We have to include the fact that the applications are actually a pretty big target for attack. I don't know how many of you are enterprise developers. I spent my time writing Java applications in enterprise back in the day. I mean, and we would pull in some weird libraries that did some cool stuff, so we didn't have to do it. But I mean, we pull stuff off of the internet all the time and put together these applications. And not surprisingly, that's an area of attack. So the second is the data plane itself. The data plane is, the connections, the requests, these are going through the data plane in the service mesh, whether that's a sidecar or whether it's somewhere else, whether it's an API gateway. So traffic's coming into and through this data plane, so that is an area of attack as well. The third is the infrastructure on which the workloads are running, the node, the hosts, the Linux machines where these are running, another avenue of attack. So the first point is that wherever you have complex code and algorithms, typically, think about things of business logic that you have to write for some of the domains in the enterprises that you're working. There's a lot of complexity that happens in there. Wherever there's complexity, there's a chance for errors and bugs and things that could lead to vulnerabilities. Whether that's in your own code that you're writing, the dependencies that you're using to bring in, or the middleware or the infrastructure technology service mesh, the data plane, any of those pieces where you could have complexity, there's opportunity for vulnerabilities. So if we first take a look at the sidecar approach, so this is what just about every service mesh does today. It's what Istio does today. Oh, we have another audience member flew in. And then into the window. All right. You take care of that one, all So what we see is the app deployed with the data plane of the service mesh deployed right next to it. And if we if we start looking at the areas of attack and what has some of the biggest surface, it's the application. And if that gets compromised, then everything in that pod, again, thinking through Kubernetes, everything in that pod becomes compromised. In that case, the data plane becomes compromised. So if you're co-locating components of your infrastructure with your application, and the application leads to a vulnerability, everything in that package or that pod is going to be considered vulnerable. If we look at the ambient approach, so we separate. We're not running sidecars. We're not running components of the service mesh data plane with the applications. We've separated them out. And in that case, if we see a vulnerability in the application, that is still separate. That doesn't automatically translate to a vulnerability and being able to attack and get to the Z-tunnel or the Istio Ambient data plane. So we have that separation between these components. Another area is, like I said, so the application, start looking at the applications of what can happen from there. Another area is the proxy itself. Envoy proxy is an extremely performant and feature-rich proxy that can be used at the edge. It can be used as a sidecar and is very frequently used as a sidecar in service mesh implementations. But if you look at all the capabilities it has, that is complexity that is being introduced into the deployment. And that's why, if you looked at the previous slide, where we had ambient running as a daemon set on the node, away from the application, so separated from the applications, the attack surface of that Z-tunnel was significantly slimmer. It is just responsible for making mutual TLS connections and capturing some telemetry. Now, we said earlier in the day that the first release of Istio Ambient uses Envoy proxy as its Z-tunnel implementation, but that was just because it was quicker to get Ambient out by leaving that. We didn't have to mess around with the XDS protocol and change it. Because if we were to switch the implementation out, there would have to be some real engineering that happens behind the scenes there. Now that is in flight. That Z-tunnel component probably shouldn't be Envoy. And there's work in the community to significantly optimize this component to give it exactly what I've pictured here. The surface area should be scoped down and should be as limited and small as possible because it's just handling connections and mutual TLS. So in the ambient data plane implementation, you see that Z-tunnel is a very hardened or slim profile of a proxy that just handles layer 4. And if it gets compromised, then you have probably a serious vulnerability, or definitely a serious vulnerability in your system. And as you saw earlier, that the Z-tunnel does represent multiple workloads. And if the Z-tunnel gets compromised, then potentially the workloads that are running on that node become compromised, which is why it's extremely important. Two big things to be taking away from here. Number one is the Z-tunnel component is not just another proxy. It's not just another workload. It needs to be treated as a secured shared component, just like you would any CNI agent. The agents that run for your CNI on your nodes, on your hosts, they exhibit a very similar security profile. All right, if they're compromised, you lose the whole node. The second thing is around operational and upgrades. Like I said, the number one thing that we focused on for Istio Ambient is around simplifying how you do upgrades, minimizing the impact, or removing completely, if you can, the impact to applications. Because it shouldn't be this complex orchestrated thing to upgrade your service mesh. You should be able to update the components independently and separately from your applications. And just like other components that are shared on the layer 4 path of your service mesh down into the Linux kernel, these are software. There's going to be bugs, there's going to be CVEs. you got to be able to find them and patch them as quickly as possible, and do that without interrupting and taking down your applications. So just like you would patch your CNI, just like you would patch your kubelet, just like you would patch your Linux kernel, we want to treat the ztunnel component along the same lines as a critical shared component, which is that's that slide. And then the last, so we looked at the applications, we looked at the data plane components, and lastly, we want to look at the node itself. And basically, this is not going to be very service mesh specific. If your node gets compromised in your Kubernetes cluster, that's a very serious, security problem. If you get access to the node, it doesn't matter if you're in sidecar mode or ambient mode or whatever. If you have access to what's happening on that node, you have the ability to sniff and look at all of the data that's happening and flowing through and on that node. So that would be, never mind your kubelet then becomes compromised, and all the other shared components. So does your mesh, regardless of what mode, your data plane mode you're running in. So, securing the Linux hosts and your node is outside the scope of this talk, but extremely applicable to your security posture. Okay, so as we start to, so now we looked at how things work. We looked at a few of the attack vectors that we want to keep in mind when we're installing and using Ambient. There's a handful of questions that come up, like this one around mutual TLS. We've had this quite a few times, but so basically, if you go back to the slide where we saw the traffic from outside comes into a node, and it might come in encrypted because it's mutual TLS. In the sidecar mode, that mutual TLS connection will end at the pod. In the ambient world, that mutual TLS connection will end on the ztunnel. And then the traffic from the ztunnel will be plain text to the workload. But then actually, if we look back at the sidecar mode, we also saw that in sidecar world, where? Now I don't remember exactly which slide that would be, but actually we'll just look at this slide. In the sidecar world, traffic, when it leaves the sidecar and goes to an application, is also unencrypted, right? So now the question really is it more secure in the sidecar world because the mutual TLS is going all the way to the sidecar versus ambient, where it's just going to the ztunnel? But in the ztunnel world, the traffic going from ztunnel to the workload is unencrypted. In sidecar world, sidecar to the application is unencrypted. All right, so we do get this question and quite a bit. And I should just kept going. Here's a good illustration of that. Here's the sidecar mode. Across the network, it's secure. On the host, when it gets to the sidecar, that traffic between the sidecar and the application is plain text. In ambient mode, across the network, it's mutual TLS. Into the node, it becomes plain text. And so then that question is one more secure than the other? It really just comes down to, does it make sense to secure the traffic on localhost? Does it make sense to secure traffic on the node with mutual TLS? And if you look at the various attack vectors and like what can happen, like we said earlier, if you compromise the node, none of this matters. Whether it's insecure, unsecure, whatever, it doesn't matter. And then it just comes down to, well, let's say you don't compromise a node, who has access to be able to do things like TCP dump and capture traffic and all that stuff? This now just comes down to basic Linux administration. Right, Linux is a multi-user, highly contended Linux, secure Linux. It's an operating system that is built for these use cases. This just becomes a Linux administration problem. So, is it more secure in sidecar mode? We don't think so, because if you get access to the node, you're going to be able to NS enter into any of the containers and look at any of the traffic, whether it's in ambient mode or sidecar mode. I don't have a demo because this is not my laptop, but let's recap. So the data plane so Ambient is a new data plane option for Istio. Like we said earlier, it was just released a month ago. There's some refinements and optimizations that we're doing. We're hardening it. We're battle testing it with real customer use cases, and we hope to have some initial use cases within the next few months, and then ideally, be production ready in the next 6 months or so. We're working extremely hard on that, both from the solo side as well as the open source community side. We believe that we're not trading off any of the zero trust properties when we adopt ambient mesh, and in certain cases, even improving the security posture of the data plane. The Z-tunnel component is a shared layer 4 component that should be treated at the same level of criticality that any of the CNI agents or shared, the kubelet that would run on any of these hosts should be treated with the same level of security concern. And because of the operational improvements, to be able to update, upgrade, patch Istio without disturbing the applications, you should be able to do that more frequently, or at least a better scheduled frequency, versus waiting to do it with the applications. Who knows how frequently or how often or what the schedule is for how applications get updated. But from a platform perspective, we need to be consistent in patching and be able to do that without disrupting our applications. So I'll leave with some takeaways. I highly encourage, if you get a chance, to do the hands-on workshops. These are we always run these free. We don't ever charge for this type of stuff, even with the certification. And we're running a bunch of them today. I think at 2:30 we're running so we've had the Cilium workshop, and we did the Ambient workshop. We're doing a getting started with Istio workshop. So I know a lot of the material up until this point has been sort of probably intermediate or some of it advanced. For those of you that are still, trying to immerse yourself in this world and understand it from a little bit of more of a beginner, I would say the workshop at 2:30 that we're having here on Istio would be a really good place. Some other things that we're giving away, like books, like the Istio Ambient Explained, Istio in Action. Those will be given away at the various book signings, and then. If you can't make it to the hands-on in-person workshops here, go to Solo Academy. These are all online. We use Instruct as our platform, and they're self-paced, and you can get real hands-on experience without cutting yourself too hard, because these are kind of built for people to actually walk through and be successful with them. That's all I have. Happy to take a couple questions.